Model evaluation in AI. Beginner level. Introduction. After building and training a machine learning model, it is important to measure how well the model performs. This process is called model evaluation. Model evaluation helps determine whether a model is accurate, reliable, useful for real-world predictions. Without evaluation, we cannot know if the model is working correctly or making many mistakes. Model evaluation is a critical step in machine learning workflows and AI development. What is model evaluation? Model evaluation is the process of measuring the performance of a machine learning model using testing data and evaluation metrics. In simple words, model evaluation equals checking how good the AI model is at making predictions. Example concept. Trained model means testing data means performance measurement. This helps determine how well the model performs on new unseen data. Why model evaluation is important. Evaluating a machine learning model is essential for several reasons. Measure prediction accuracy. Evaluation metrics tell us how correct the model's predictions are. Detect overfitting. If the model performs well on training data but poorly on new data, it may be overfitting. Example concept. High training accuracy means low testing accuracy. Improve the model. Evaluation results help developers improve models by tuning parameters or selecting better algorithms. Compare models. Evaluation allows developers to compare multiple models and choose the best performing one. Training data versus testing data. To properly evaluate a model, the dataset is usually divided into training and testing data. Example concept. Dataset. Training data means model training. Testing data means model evaluation. The testing dataset contains data the model has never seen before. This ensures the evaluation is fair and realistic. Common model evaluation metrics. Different metrics are used depending on the type of machine learning problem. Accuracy. Accuracy measures the percentage of correct predictions made by the model. Example. Accuracy equals correct predictions, total predictions. Example. If a model correctly predicts 90 out of 100 samples, the accuracy is 90%. Accuracy is commonly used for classification problems. Precision. Precision measures how many predicted positive results are actually correct. Example concept. Precision equals true positives, predicted positives. Precision is important when false positives are costly. Example. Fraud detection. Recall. Recall measures how many actual positive cases are correctly identified. Example concept. Recall equals true positives, actual positives. Recall is important when missing a positive case is dangerous. Example. Disease detection. F1 score. The F1 score combines precision and recall into a single metric. Example concept. F1 score means balance between precision and recall. It is useful when datasets are imbalanced. Confusion matrix. A confusion matrix shows the detailed results of classification predictions. Example. Actual, predicted positive negative. Positive true positive false negative. Negative false positive true negative. Example concept. Prediction results means confusion matrix means model analysis. This helps understand where the model makes mistakes. Evaluation metrics for regression. For regression models, different metrics are used. Examples include mean squared error, MSE, root mean squared error, RMSE, mean absolute error, MAE. Example concept. Prediction error means regression evaluation metrics. Lower error values indicate better model performance. Example Python code. Example model evaluation using Python. From sklearn. Metrics import accuracy _ score. Libraries like scikit-learn provide built-in functions for evaluating machine learning models. Model evaluation workflow. Typical evaluation process. Dataset. Down pointing arrow. Split into training, testing. Down pointing arrow. Train model. Down pointing arrow. Evaluate model. Down pointing arrow. Improve model. This process ensures the model performs well before deployment. Real-world applications. Model evaluation is essential in many AI systems. Healthcare. Ensuring diagnostic AI systems produce accurate predictions. Finance. Evaluating models used for credit risk and fraud detection. Autonomous vehicles. Testing models that detect road objects. Recommendation systems. Evaluating how accurately systems recommend products or movies. Concepts learned from model evaluation. Understanding model evaluation helps beginners learn. Checkmark how machine learning models are tested. Checkmark how prediction accuracy is measured. Checkmark how to improve model performance. Model evaluation is one of the most important steps in machine learning development. Simple definition. Model evaluation. The process of measuring how well a trained machine learning model performs using testing data and performance metrics. Final summary. Model evaluation is a critical step in artificial intelligence and machine learning. After training a model, developers measure its performance using testing datasets and evaluation metrics such as accuracy, precision, recall, F1 score, and error metrics. These evaluation techniques help determine whether a model is reliable, identify potential problems like overfitting, and guide improvements. Understanding model evaluation is essential for building accurate and trustworthy AI systems.